Hello and welcome to the Statistics 512 final project presentation. We are group number 2 and our topic is happiness. Intuitively, everyone acknowledges that happiness is important and good to have. Happiness level, however, is playing an increasingly important role in shaping policy, and as a consequence, studies have been done to better understand the relationship among someone's happiness and their level of engagement with work and organizational commitment. Since many factors contribute to a person's happiness level, the goal of this project is to identify if there is a best model to better understand the relationship between these underlying factors and the perceived level of happiness of a given population. To that end, we've defined two research questions. Question number 1 is to determine what's the best linear regression model to predict the letter score. And question number 2 is based on the selected or proposed model, which factors contribute to people's happiness and to what extent they influence someone's happiness level. The data set is based on the World Happiness Report, which is published on a yearly basis and includes a wide variety of data, but its most important source is the Gallup World Poll. The data set is composed of data from 153 countries with a variety of information in it. We only kept the key variables and factors that are required for our analysis, and in our screening process we discarded all of the other information, which included geographic information as well as descriptive statistics. Our data set then is made up of 6 explanatory variables, which are considered to have correlation with happiness, which is in turn measured by the letter score. So the variables are GDP per capita, social support, healthy life expectancy, freedom of making life choices, generosity, and perception of corruption. We'll next detail the preliminary analysis.
When a regression model is considered for application, there are some basic assumptions that we make about the model and the data at hand. Following are the potential violations of those assumptions that may make a model inappropriate. In the preliminary analysis, we are going to look into those violations. For checking the linear relation of regression, we use the residual versus featured value plot. The plot shows that the regression function is linear and hence no violation of the assumption. For checking the normality assumption, we use both the normal QQ plot and a Shapiro-Wilk test. The plot shows that the residuals are normally distributed. However, the Shapiro-Wilk test, which is the formal test for normality, showed that the assumption of normal distribution of residual is violated. For checking non-constant variance of residual, again we have used the residual versus fitted value plot. From the plot, it appears that the assumption is not violated. However, the Brown-Forsyth test, which is a formal test for the heteroscedasticity or the non-constant variance, shows that the assumption of constant variance is violated. A scatter plot was used for the checking the presence of multicollinearity in the predictor variables. From the plot, it seems that some of the predictor variables are correlated. This would be further verified in the subsequent sections. For checking the presence of potential outliers, we utilize the box plot. The box plot here indicates the presence of some potential outliers. All the violations of the assumptions would be explored further and necessary remedial measures would be done in the subsequent sections.
Now we are going to describe our model building, formal diagnosis, and validation. Our first order model is a linear model where all the variables are involved. And as we can check earlier, our first order model doesn't follow a normal distribution on residuals. And also, the residuals have non-constant variance. For addressing this problem, we did a box cost procedures, and we got that the lambda should be equal to 1.25. After Y transformation, we retest for normal and constant variance on the residuals. So after this retest, we can say that the residual follow a normal distribution. However, the non-constant variance is still an issue. Next, we check for important predictors on our model. So we run a best sub function in R, and we find out that the predictor number 5, generosity, is not important in the model. We check that with the lowest CP, AACP, SBCP, and PRESP. We confirm the non-importance of the predictor generosity with a step regression model. Also, we compare the root mean square error for the full model. It means, all the variables, and the reduced model with the generosity predictor dropped, and we find out that the ARM MCE is better or lower in the reduced model. So that means that the reduced model have better predictive power. Now we check for outliers on Y. So we compute the Bonferroni critical value, and we got around 3.5. And we calculated the student side residuals, and we can see that any student side residuals is less than 3.5. So we can conclude we don't have outliers on Y.
Here, we will explore potential outliers with regard to its x values. To determine the outliers, any case exceeding 0.092 is considered the outlier. There are 4 cases that exceed 0.092. Those are case 149, case 150, case 31, and case 153. The Cook's distance plot on the right will be addressed later. Next, we will discover influence points that may negatively affect our current model. To do that, we consider Cook's distance method. So, in Cook's distance method, we conclude that there is no influential point. However, in df-betas method, we found that the case 150 has a fair influence on the betas. Note that we prefer df-betas method because our research question is to study the impact of the explanatory variables on happiness. Moving on, we will decide if our model has multi-collinearity among the explanatory variables. Generally, VIF value exceeding 10 indicates multi-collinearity. Since we drop one of the x variable, which is the generosity, we conclude that there is no multi-collinearity among the variable. Moving on the remedy for the violations we found earlier, we perform weighted least square method to remove heteroscedasticity. We will perform statistical tests later to verify if this violation is removed. Next, we perform the robust regression method to deal with the influential point. The starting weight function used was by square estimator. We also included the weight obtained from weighted least square method done earlier. To confirm that we successfully removed the non-constancy of the residuals, we performed Brown-Forsyth and Shapiro-Wilk tests on the residual. At alpha 0.01, we conclude that the residuals have constant variance and follow normal distribution. Finally, from the df-betas plot displayed here, the robust regression method managed to reduce the influence of case 150 on the betas.
Moving on to the final model report and application, we'll be talking about the potential issues found and how we went on to address them. 3 potential issues were found, and we were able to correct the 3 of them. The first is the issue of non-normal residuals. The Shapiro test and the scatter plot revealed that we had a non-normal residual issue, and this was corrected by the transformation of our y variables. The second issue was the issue of non-constancy of the variance of our residuals, and this was corrected using the weighted least square approach. The third issue we found was the issue of influential points, and we applied the robust regression in correcting this. Moving on to the research questions, we had 2 research questions and we are going to answer them in the following slides. The first research question we had was that what is the best linear regression model to predict the ladder score or the happiness score? From the line below, we can see that the model without the generosity variable was the best to predict the ladder score, because using the stepwise regression we were able to remove the non-essential variables. From the R output below, we can see the parameter estimates and their standard errors. In the second research question, we want to know what factors contribute to people's happiness and to what extent they influence a person's happiness level. Below, we have the type 2 ANOVA test and we have the stepwise regression model. So we can see that the predictors that are important have a large sum of squares as seen in the type 2 ANOVA, and we were able to drop the generosity variable because it was not important, but we can conclude from these 2 tables that the social support predictor is the most important factor that impacts a person's happiness level, and other variables such as freedom to make life choices and low GDP per capita are also important. However, we concluded that social support was the most important. In this section, we will talk about the advantages and the disadvantages of the multiple linear regression and the advantages and disadvantages of the mixed linear model used in the reference. So firstly, the advantage of the multiple linear regression is that it accounts for important factors in the model. In our model that we got, the important factors were retained while the less important ones such as generosity were dropped. And secondly, this multiple linear regression model is not too complex compared to other advanced methods such as neural network. Then also, multiple linear regression helps us in making predictions, although that was not the goal of this project, but multiple linear regression excels in that avenue. Then lastly, it helps us to have more accurate and precise understanding between our response and all the predictors. Then moving on to the disadvantages of MLR, it is very sensitive to outliers. So outliers tend to impact the results or the deductions made from the result for multiple linear regression if they are not corrected. Then number 2, extrapolation is not always optimal beyond the scope of the data sets. Then lastly, it gives optimal estimates of unknown parameters. Moving on to the mixed linear model, the first advantage of the mixed linear model is that it prevents false positive association between the response and the predictors. And the second one is that there is no assumption of independence amongst observations, unlike the MLR, which requires this assumption. Then lastly, there is no need to transform the response Y. Then moving on to the disadvantages of the mixed linear model, the first one is that it is much more complex than other methods and it cannot control for variables that vary over a long time. For example, the GDP per capita variable seen in our model is an example of such. Moving on to the conclusions, from our model we can conclude that a multiple linear regression model was the best model for this analysis. It highlighted the impact of the predictors on our response variable. Then secondly, since we transformed our Y variable, we used the back transformation method using this equation to transform our Y variables back to the original. So in case if predictions were to be made, this would be appropriate. Then also the residual plot and an adjusted R-square value of about 74% helps us to conclude that the variables left in the final model could explain most of the variance in the ladder score or the happiness score. Then lastly, our data set had many violations. Although they were all corrected, extrapolation should not be done beyond the scope of the selected model. This shows the references used for our report. Thank you for your time.